Okay, so I just want to give you a brief understanding of the concept behind the average rate of change. Let's say that this blue curve here, that's a cubic curve. We're going to call it f of x, okay? And let's say that we want to identify the average rate of change between a couple points. Now the average rate of change is always going to be between 2 points, okay? So let's say that I want to know the average rate of change between -6, -4, that's this point here, and 8, 6, which is already over here, all the way over here. And so we know the formula. We know that the formula goes f of b minus f of a over b minus a. Well, remember that b and a make up an interval, right? So the interval from a to b, okay? And here, our x values are -6 and 8. And that must mean that a must be -6 and b must be 8. Whoops, excuse me, bracket. And so, if we wanted to identify the average rate of change between -6, -4, and 8, 6, what we would do is we would do f of 8 minus f of -6 over 8 minus -6. And how would we do that? Well, f of 8 is given to us. The output, f, at the input 8, when the input is 8, the output is 6. And so this is 6 minus, when the input is 6, the output is -4. So we can just put a -4 there. It's really easy to do with graphical information when you already have the output values. And then it's over 8 minus -6. Well, minus negative, that means 8 plus 6. Okay? And so 6 minus -4, that's 6 plus 4, so that's 10. 8 plus 6 is 14, and that's going 10 over 14 is the same thing as 5 over 7. So the average rate of change between -6, -4, and 8, 6 is 5 over 7. Now let me show you something. One way that we can understand this is we can draw a straight line between these 2 points. And that's what this is. 5/7, very simply, is the slope of the line that connects -6, -4 to 8, 6. And I'll show you. Rise over run. Here, we're going to go from -6 up. Well, sorry, it's -4 down here. Here's -4. Okay? The height is -4. And we're going to go up to 6. See that? So the rise is 6 minus -4. That's 10. So it has a rise of 10 and a run that starts at -6 and goes up to 8. And 8 minus -6, the distance from here to here, is 14. So we have rise of 10, run of 14, and so the slope of this line is 10 over 14 or 5 over 7. And so what I'm saying is that the concept of the average rate of change is if you were to connect the 2 points on the graph of the function you're dealing with, if you were to connect them with a straight line, the average rate of change very simply is the slope of that line. Okay? All right, well, can we do any others here? Well, yeah, we could do this. We could do the average rate of change between 6 -4 and let's say 1, 5. Okay? So if we do 1, 5 and 6, -4, we would do f of, so a would be -6, b would be 1. F of a would be -4, and f of b would be 5. So if we're going to do f of 1 minus f of -6, this is f of b minus f of a, over b, which is 1 minus a is negative 6. F of 1 is 5. So this is going to be 5 minus f of negative 6 is negative 4. So 5 minus negative 4 over 1 minus negative 6, that's like 1 plus 6. 1 plus 6. So 5 minus negative 4 is 5 plus 4, that's 9 over 1 plus 6 is 7. And so the slope is 9 over 7, which is steeper than 5 over 7. 5 over 7 is less than 1. 9 over 7 is greater than 1, so it's steeper than 1. And it sure is. Look here. If I draw a line between these 2 points, you can see that this red line is steeper than the purple line. This line is steeper, and it has a slope of 9 over 7. Okay? And now we could also do the average rate of change between 1, 5 and 8, 6. And if we did, we would put a straight line between here and here. We could also do the average rate of change between 1, 5 and 7, negative 2, and it would create a straight line here. It would be the slope of the straight line between here and here. Okay? And so what I'm saying here is this, is that the concept of the average rate of change on an interval is the slope of the straight line that connects the 2 points of the function on that interval from A to B.